Hello class, in this video I will be demonstrating how to restate a standard maximization problem using equalities. Then I will create the simplex tableau matrix, which is the matrix that will be used to solve this type of problem. Let's begin. So restate the following linear programming problem by introducing slack variables. Well, here is the function that we are trying to maximize. And this is called the objective function. This objective function is subject to three constraints right here. And each one of these constraints is an inequality. And we're going to use slack variables to write each of them as an equality. So let's do that. So you want to maximize z is equal to 3x sub 1 plus 2 times x sub 2 plus x sub 3, subject to the following constraints. So the first constraint I'm going to add the first slack variable. And I'm going to set that equal to 150. And I'm going to do the same thing with the second constraint. Now I'm going to set the second constraint equal to 200 because I added the second slack variable. And now I will do the same thing. I will introduce a slack variable to the third equation. So the problem has now been rewritten using slack variables. And now that all four of these equations are, well, equalities and not inequalities, we can now enter them into what is called the simplex tableau matrix. So what I'm going to do is I'm going to start by labeling the columns in the simplex tableau matrix. And I'm going to start with all the variables of x. Next, I'm going to list the slack variables. Next, I'm going to list the variable z, and I'm going to place a vertical line after the z and a horizontal line at the bottom. And I'm going to put the braces around each side. Okay, so what goes in each one of these entries here? So starting with the first row is going to be the first constraint. So the coefficients of the first constraint are going to go into the first row. So in this case, that will be 2, 1, 1, 1. Now, there is no second slack variable in the first constraint, and there's also no third slack variable in the first constraint, so we're going to write those as 0, 0. There's also no z in the first constraint, so I'm going to write a 0 there also, and then place the 150 at the very end. The second row is going to represent the second constraint, so those coefficients are the following: 2, 2, and 8. There's no first slack variable present in the second constraint, so that's going to be a 0, and a 1, 0, 0, 200. And I will do the same thing for the third row. The third row will represent the third constraint. Okay, so now that we have all of the constraints in this matrix, we now need to enter the function that we're trying to maximize. So what I'm going to do is I'm just going to extend this vertical line a little bit further, like such. And I'm going to make this side just a smidge neater. Like such. Okay, so notice that in the simplex tableau matrix, all of the variables are to the left, and then the constants are over here on the right. If we take a look at the problem that we're trying to maximize, that is 3x sub 1 plus 2x sub 2 plus x sub 3 is equal to z. So what I'm going to do is I'm going to rewrite this so all of the variables are on the same side of the equal sign. And I'm going to do that by bringing the x's over to the right. So this is the same as negative 3x sub 1 minus 2x sub 2 minus x sub 3 plus z is equal to 0. So now I'm going to write all of these coefficients underneath the horizontal line here in the simplex tableau matrix. So this would be negative 3, negative 2, negative 1, and then 0, 0, 0, because there are no slack variables in the function we are trying to maximize. This will be a positive 1, and then the last entry will be a 0. So this is the matrix we are going to use to solve the standard maximization problem. And we won't solve this in this video, but I'm going to show you the techniques that you're going to need to be able to solve the standard maximization problem using the simplex tableau matrix.